In this video, we're going to learn how to factor not only the difference of two cubes, but also the sum of two cubes. Let's just review our basic cubes. What are cubes? 1 cubed is 1. 1 times 1 times 1. 2 cubed is 8. 2 times 2 times 2. 3 cubed is 27. 4 cubed is 64. Now that's also a perfect square. Remember that 8 times 8 is 64. So something else in the problem is going to indicate that this is a cube, not a square. And then we have 5 cubed is 165. 6 cubed is 216. And then I'm going to skip to 10 cubed. And you should be familiar with those basic cubes. So how do we factor the sum of two cubes? Sum meaning we have a plus sign, a cubed plus b cubed. Well, this is the formula, but I'm not going to teach it by that formula. I want you to recognize what goes in this first parenthesis, because that's going to be key here. That first parenthesis, notice it matches with the plus sign. It matches the problem, except it leaves out those exponents. So once we could get that first parenthesis, the way we're going to get the second parenthesis is to know we square what's here, square that, and then notice the middle is we multiply those two together, AB, but we take the opposite sign. It also works for the difference of two cubes. This parenthesis is the same as the problem except for the cubes. And then we go through that same process that if we have a at the beginning, we have a squared, b at the end, that's b squared, so we square square, and then we multiply a times b, always ab, but take the opposite sign. So you can memorize that formula or memorize the process. So let's look at the first two examples, just real basic, the sum of two cubes. So first of all, you need to recognize these are cubes and ask yourself, what cubed is x cubed? Well, x. Then we have a plus sign. What cubed is 8? 2. There's part of your answer. That's that first little parenthesis. It's always a binomial multiplied by a trinomial. So how do we get that trinomial? Again, we could do the formula, or the way I do it is I go, okay, I square that. That goes at the beginning because it was at the beginning of the parenthesis. I square that number, and it goes at the end because it was at the end of the parenthesis. When you square something, it's going to be always positive. Then how do you get that middle term? We multiply those two things together, so that's 2x, and we take the opposite of that sign. Not that complicated. Now the good news is the way, if you memorize the process as opposed to the formula, you only need to know one process. Formulas, you need to know two, because the process also works for the difference of two cubes. We have that binomial. So what cubed is x cubed? X. Keep the same sign. Then what cubed is 125? 5. So that's our binomial. Now we need our trinomial. What goes at the beginning of the parenthesis? X, but we need to square it. What goes at the end of the parenthesis? 5, but we need to square it, and that's always going to be positive. Then how do we get the middle? We multiply those together, and we take the opposite of that sign. That's your answer. Now I need to say that this trinomial is a prime trinomial. You will not be able to factor it further. Your cube answers are a binomial times a trinomial. So let's look at this very first example. Want to remind you, you always look for that GCF. So we have some more complicated numbers here. I see some cubes. I don't see a greatest common factor. So I know I need to start with my binomial. Now we have numbers and letters combined. So what cubed is 125 is 5, but I also need the x. I need the same sign. And then what cubed is 27 is 3, but I also need the y. Now I have the long parenthesis with 3 terms. How do I get them? Okay, I look at the first one and I have to square that. Now be careful. Squaring 5x means 5x times 5x, which is 25x squared. And that goes there. Then I need to square that. And so that's 3y times 3y, which is 9y squared, which goes at the end of the parentheses. That's always positive because I've squared it. Then I'm going to multiply that together. So 5 times 3 is 15xy. Alphabetical order is kind of nice. And then take the opposite of that sign. There's your answer. Let's look at the second example. Well, I see that they're cubes, but 40. What cubed is 40? I can't think of anything. So maybe this is prime. No, the GCF. What are both of these numbers divisible by? 5. So if I divide both of them by 5, remember we need to write that 5 as part of our answer. 5 goes into 40 8 times. 5 goes into 135 27 times. Now look inside those parentheses. That's the sum of two cubes. So on the next line of paper, I'm going to bring down my 5. I'm going to write my binomial. What cubed is 8x cubed? 2x. Same sign. What cubed is that? 3y. Now I need my trinomial. So I square that. Remember 2x times 2x is 4x squared. I square that. 3y times 3y is 9y squared, and that's always positive. Then I multiply that together. So 2 times 3 is 6, and then there's an x and then the y, and I want to take the opposite sign. There's your final answer. Number 3. I see 4 things, not 2. I see more than cubes. I see y to the 4th. What should we do? Well, remember, if you have 4 or more terms, you want to try grouping as a process. And when we group, you might try the first 2 and the last 2. So this is a good time to review grouping. What do these first 2 have in common? I think a y cubed. So let's divide each of them by y cubed, and we would have y minus 2 left. What are those both divisible by? Well, since this first one is negative, I'm going to take out a negative, and I think 64. Let's divide both by negative 64. That would go in there 1y time. That's minus 2. Now remember, when you're grouping, you want to know if you can keep going if these match, which they do. And then that's our GCF. So I'm going to take out the y minus 2, and that leaves me y cubed minus 64. Not done yet, because now I have the difference of two squares. No, not squares, but cubes. So in the next line, I'm going to bring down my y minus 2. Then I have my binomial times my trinomial. So for here, I need a y, I need a minus sign, not squares, but cubes. What cubed is 64? Is 4. Then here, I want to square this first term. I want to square this second term, make it positive. Then I want to multiply those together and take the opposite sign. Final answer. So this problem, think about it. It has grouping involved and it has cubes. So that's combining two different types of factoring. Let's look at this last example. Very much like the last one. Ooh, but man, there's just so much stuff. So we could try grouping first. That looks kind of scary. I'm thinking let's just look for a GCF. I think a lot of these are divisible by the same thing. So I look at 12 and 75, and I know those are both divisible by 3. And then I see that they all have some x's, and the lowest power is an x. They all have some y's, and the lowest power is 1. So I'm going to divide all of these by 3xy. and see where that leads me. Wow, that looks even uglier. Well, now I think I'm going to try grouping. Okay, so I'm going to group these first two, or maybe you want to rearrange it and put the 4's together and then the y's together. That might be helpful. Let's do that. Right, so I'm going to go ahead and rewrite this with my 4's first, and then I'm going to put my 25's. Alright, now let's group. So if I put those together, what do they have in common? Now what you have to be careful about is leave that 3xy alone. So I'm just going to put that big bracket. I'll deal with that at the end. So what do those two have in common? A 4 and an x squared. If I divide both of them by 4x squared, that's going to leave me x squared minus y squared. Now these are both, obviously they have a 25, but since that negative's in front, I'm dividing by negative 25. And that's going to leave me a positive x squared and a minus y squared. Well, when you group, you want something to be the same, and it is. So again, I'm just leaving that 3xy. I'm taking out my x squared, y squared, that's the same. So kind of dividing by that, seeing what I have left. Now those aren't cubes. What are those? Those are the difference of two squares. So I have 3xy. How do you factor that? How do you factor that? So this problem had GCF, it had grouping, and it had not just one, but two difference of two squares. So sometimes when you look at a problem, you're not too sure where it's going to lead you. You just start trying things that you should recognize. GCF is always at the top of the list. If there's more than 3 terms, so 4 or more, you want to do grouping and then go from there. Could it be squares or later on trinomials? Could it be cubes? You just have to start thinking.